Now we were just looking at how to predict the shape of a parametric equation, the shape of its graph, based off of its two coordinate functions, right? My x is a function of t, and my y is also a function of t. Now, another way that I could have thought about this is to look at those equations specifically. X is twice the sine of t. Well, the sine function is only ever giving me a number between -1 and +1, which tells me that of course my x has to be between -2 and +2. I had to think about that real hard with algebra down over here, but that's the only range that my x coordinate can come from. And similarly, the only range that my y coordinate can come from would be y has to be a number between -5 and +5. Why is that? Well, any value of t here can only make cosine be a number between -1 and +1. So of course, 5 times that would have to be a y coordinate between -5 and +5. So this gives me a really handy way to plot ellipses. If I want an ellipse, let's say that it should be 10 units wide, then my x here should be 5 times the trig function. And if I want it to be 7 units tall, it should be 7 times the cosine function. So let's zoom out and see if that prediction holds. So let's see that tracing. There is my movable point. The smallest it gets on the x-axis is -5. The largest it gets on the x-axis is +5. The smallest it gets on the y-axis is -7. And the largest it gets on the y-axis is +7. And so here is the shape that it is tracing out. Okay, so that's pretty cool. Now, this idea of a point tracing out a curve allows us to deal with lots of graphs, lots of shapes that we couldn't have before. Now, if we had some function, let's say y equals f of x, what do I want for my f of x here? How's about f of x is e to the power x, or x I said, minus 2 times sine of x. How about plus x over 2? There's a function. And I know how to graph this. I'm just lighting up all of the x and y coordinates where this equation is true. It turns out that even graphs like this can be written parametrically. How do I write a formula for a moving point to follow so that it always lands on this graph of the function f of x? Well, whatever value I pick for x, let's just say that's a right now, then my y coordinate needs to match the formula of my function at that same coordinate. So here is my movable point. And now it is staying along this curve. I've told it to go between x equals 0 and x equals 2 times pi. So let's see that graphed parametrically. My x coordinate is always going to be t. My y coordinate is always going to be f of t. So let's light that up. Here are exactly those coordinates. If I want to see more of the graph, I'll say let's have t start at say negative 10, go up all the way to positive 20. Now I see a little bit more of that curve. So every graph that we've worked with, graphs of functions, also has a parametric form, just t as the x coordinate, f of t as the y coordinate.